Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video is entitled The Essential 17, is comprised of 17 different problems designed to cover the most necessary skills for a student to master prior to taking the MAT 1033 Intermediate Algebra Final Exam at St. John's River State College. Write an equation in standard form for the line that contains 1, -2, and 7, 6. We first start with the slope formula, which is the slope, or m, equals y1 minus y2 over x1 minus x2. Looking at our points, we identify one point as x1, y1, and the other as x2, y2, and fill in the numbers in our equation. When we complete the subtraction, we get -8 over -6, which simplifies to 4 over 3. Next, we take the point slope form and fill in the numbers. We simplify to get y plus 2 equals 4x over 3 minus 4 over 3. The standard form of the equation is in the form ax plus by equals c, where a, b, and c are integers. Therefore, we multiply each term on both sides of the equal sign by 3 to eliminate the fraction, giving us 3y plus 6 equals 4x minus 4. Now we move the variable terms to one side by subtracting 3y from both sides, and move the integer to the other side by adding 4 to both sides. Our final answer is then 4x minus 3y equals 10. Write an equation in slope-intercept form for a line that contains 4, -3, and is perpendicular to 4x minus y equals 5. First, we take the given equation and put it in slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept, and both are rational numbers. We do this by subtracting 4x from both sides to get -y equals minus 4x plus 5. We then multiply all terms on both sides of the equal sign by -1 to get y equals 4x minus 5. The slope of the line formed by this equation is 4. So the perpendicular slope will be the opposite inverse, which is -1/4. Next, we go to our slope form and fill in the numbers to get y minus a -3 equals -1/4 times the quantity of x minus 4. When we simplify and use the distributive property, we get y plus 3 equals -1/4 x plus 1. We then subtract 3 from both sides to get our final answer, y equals -x over 4 minus 2. Graph the inequalities 2x minus 5y is less than 10 and y is greater than or equal to -4. First, we take 2x minus 5y is less than 10 and put it in slope-intercept form. We first subtract 2x from both sides to get -5y is less than 10 minus 2x. We then divide both sides by -5, which switches the direction of the inequality, giving us y is greater than 2x over 5 minus 2. We start with graphing the line, starting with the y-intercept, -2, and the slope, which is 2 over 5, and draw the line. Since y is greater than, we make the line dashed and fill in above the line. Next, we add a line for y at -4. Since y is greater than or equal to -4, we use the solid line and fill in above. Next, we look at the conjunction in between the equations. If that conjunction were or, then our graph would be complete, filling in areas that apply to either equation. This conjunction is and, so we only fill in the area that applies to both equations. Use the substitution method to solve the system of equations -3x plus y equals 11 and 4x plus 3y equals 7. For substitution, we need to put one of the equations into an x equals or y equals form. Since the first equation has a y with no coefficient, this one will be the easiest to use. So take -3x plus y equals 11 and solve for y. We do this by adding 3x to both sides to get y equals 3x plus 11. Next, we take the other equation and substitute y for what we have just determined y equals, which is 3x plus 11. This gives us 4x plus 3 times the quantity of 3x plus 11 equals 7. We use the distributive property to remove the parentheses and get 4x plus 9x plus 33 equals 7. Combine our like terms and subtract 33 from both sides gives us 13x equals negative 26. Divide both sides by 13 to get x equals negative 2. Next, we take the known x value and substitute it in the first equation to get y equals 3 times negative 2 plus 11, or y equals negative 6 plus 11, or y equals 5. Use the elimination method to solve the system of equations 3x plus 2y equals 5 and 5x minus 7y equals 29. To complete this, we need one of the coefficients to be the same in both equations. So let's look at the x coefficients. If we multiply each term on both sides of the first equation by 5 and all terms on both sides of the second equation by 3, we get 15x plus 10y equals 25 and 15x minus 21y equals 87. Now we simply subtract. 15x minus 15x equals 0. 10y minus a negative 21y is 31y, and 25 minus 87 is negative 62. The result is 31y equals negative 62. When we divide both sides by 31, we get y equals negative 2. Next, we take the known value of y and substitute it in one of the two equations. For this method, it does not matter which of the two equations is used. So 3x plus 2 times negative 2 equals 5, or 3x minus 4 equals 5. Add 4 to both sides to get 3x equals 9. Divide both sides by 3 to get x equals 3. Simplify the expression 1 plus 1 over x minus 2, all over x plus 1 over x minus 2. We start this by multiplying x minus 2 times both the numerator and denominator. We then distribute x minus 2 to both terms inside the parentheses. This will cancel the compound denominator, giving us x minus 2 plus 1 over x times the quantity of x minus 2 plus 1. The new numerator simplifies to x minus 1, and the new denominator simplifies to x squared minus 2x plus 1. This new denominator can be factored into x minus 1 squared, or x minus 1 times x minus 1. One of these will cancel with the numerator to leave us the final answer, 1 over x minus 1. Add, subtract, multiply, or divide as indicated. 3 over x plus 4 plus x minus 1 over 3x squared plus 11x minus 4. In order to add fractions, a common denominator is needed. First, we see that the denominator in the second term can be factored into x plus 4 times 3x minus 1. Now we see that a common denominator may be achieved by multiplying the first term by 3x minus 1 over 3x minus 1. This gives us 9x minus 3 over x plus 4 times 3x minus 1 plus x minus 1 over x plus 4 times 3x minus 1. Now that our denominators are the same, we can just add the numerators to get 9x minus 3 plus x minus 1 over our common denominator. We simplify to 10x minus 4 over the common denominator. We can factor out a 2 in the numerator to give us our final answer, 2 times the quantity of 5x minus 2 over x plus 4 times 3x minus 1. Add, subtract, multiply, or divide as indicated. X squared minus 9 over 6x minus x squared divided by 3 minus x over x squared. First, we understand that dividing fractions can change to multiplying fractions by inverting the second term. So this operation is equal to x squared minus 9 over 6x minus x squared times x squared over 3 minus x. When looking for terms to cancel, we need to factor each term completely. Since we are multiplying, canceling can be made between either numerator and either denominator. The numerator in the first term can factor into x minus 3 times x plus 3, and an x can factor out of the first denominator. The second denominator may not factor using a common variable or integer, but by factoring out a negative 1. The term now matches the x minus 3 term in the first numerator, and the two can cancel. The factored x in the first denominator can then cancel with one of the x's in the second numerator. Now we multiply both numerators together and both denominators. Then simplify to get x times the quantity of x plus 3 over negative the quantity of 6 minus x, or x times the quantity of x plus 3 over x minus 6. Solve the equation. 3 over y minus 3 minus 3 over y squared minus 5y plus 6 equals 2 over y minus 2. First, we see the denominator in the second term can be factored into y minus 2 times y minus 3. Next, we multiply each term by the common denominator, which is y minus 2 times y minus 3. In the first term, the y minus 3 cancels, leaving us 3 times the quantity of y minus 2. In the second term, y minus 2 and y minus 3 cancels, leaving us a negative 3. In the third term, the y minus 2 cancels, leaving us 2 times y minus 3. We next apply the distributive property to both parentheses to get 3y minus 6 minus 3 equals 2y minus 6. We combine like terms to get 3y minus 9 equals 2y minus 6. Add 9 to both sides and subtract 2y from both sides to get 3y minus 2y equals negative 6 plus 9, or y equals 3. Unfortunately, we are not done. With the variable in the denominator, we must check our answer to ensure the solution is in the domain of the initial equation. When we substitute y for 3, we see that in the first term we get 3 minus 3 in the denominator. Since we cannot divide by 0, this means the equation has no solution. Simplify the expression, negative 64 over 125, taken to the power of negative 2 over 3. First, we deal with the negative exponent. We do this by taking the inverse of the rational number, negative 125 over 64, and take it to a positive 2 over 3 power. Next, we take each numerator and denominator to the 2/3 power. The 2/3 power means squared and cube root. So we take the cube root of negative 125 to get negative 5, and take the cube root of 64 to get 4. We then square both. Negative 5 squared is 25, and 4 squared is 16, giving us a final answer of 25 over 16. Simplify. 3 minus 2 times the square root of 2, quantity squared. First, let's express this as the product of two binomials. When we FOIL out the two binomials, we get 9 minus 6 square root of 2 minus 6 square root of 2 plus 8. When we simplify, we get 17 minus 12 square root of 2. Rationalize the denominator. 3 over the square root of 17 plus 4. To rationalize the denominator, we take the conjugate of the denominator, which is the square root of 17 minus 4, and multiply it by the numerator and denominator. This results in 3 times the square root of 17 minus 12 over 17 minus 16. The denominator simplifies to 1, which can be removed, leaving us our final answer, 3 times the square root of 17 minus 12. Simplify. Assume all variables represent positive real numbers. 18y plus 3 times the square root of 28y cubed over 12y. Here we first work inside the radical. 28 is 4 times 7, and y cubed can be expressed as y squared times y. We know that the product of two numbers inside the radical is equal to the product of the separated radicals, so we can separate each one. The square root of 4 is 2, the square root of y squared is y. This leaves us with 18y plus 3 times 2 times y times the square root of 7y over 12y. When we simplify, we get 18y plus 6y times the square root of 7y over 12y. We can factor a 6y out of the numerator, which cancels with the denominator, to get the final answer, 3 plus the square root of 7y over 2. Solve the equation, the square root of 5x plus 1 minus 11 equals 0. First, we add 11 to both sides, giving us the square root of 5x plus 1 equals 11. Then we square both sides of the equation. On the left, squaring a square root cancels the operation, leaving 5x plus 1 and on the right side, 11 squared equals 121. Next, we subtract the 1 from both sides, then divide both sides by 5. This leaves us with the final answer, x equals 24. Use the square root property to solve the equation z plus 8 quantity squared plus 11 equals 7. First, we subtract 11 from both sides, leaving us z plus 8 quantity squared equals negative 4. Now we square root both sides. When we do this, the square root property tells us that the right side of the equation could be a positive or a negative. So we express it as plus or minus the square root of negative 4. On the left side, the square and square root cancel each other, leaving z plus 8. The square root of 4 is 2, and the square root of negative 1 is I. We then subtract 8 from both sides, leaving us z equals plus or minus 2i minus 8. This can also be expressed as two solutions, z equals 2i minus 8 and z equals negative 2i minus 8. Complex numbers are more appropriately expressed with the integer first followed by the complex term. So z equals negative 8 plus 2i and negative 8 minus 2i. Use completing the square to solve the equation. R squared minus 10r plus 18 equals 0. First, we subtract 18 from both sides, giving us r squared minus 10r equals negative 18. We then select the integer that will complete a perfect square. We do this by dividing the negative 10 integer by 2 and taking its square. Negative 10 divided by 2 is negative 5. Negative 5 squared is positive 25. We then add 25 to both sides of the equation. The left side can now be factored into r minus 5 quantity squared equals 7. When we square root both sides, remember the square root property. We get r minus 5 equals plus or minus the square root of 7. At this point, we separate the equation into two parts. R minus 5 equals the square root of 7, and r minus 5 equals negative the square root of 7. Solving the first one, we add 5 to both sides to get r equals the square root of 7 plus 5. In the second equation, we add 5 to both sides to get negative square root of 7 plus 5. It is more appropriate to write expressions with root terms with the integer first, followed by the root. So r equals 5 plus the square root of 7, and 5 minus the square root of 7. Use the quadratic formula to solve the equation 2x squared plus 3x equals 1. First, we express the equation in quadratic form, ax squared plus bx plus c equals 0, which in this case, we need to place all of the non-zero terms on the left side of the equation. When we subtract 1 from both sides, we get 2x squared plus 3x minus 1 equals 0. We remember the quadratic formula as negative b plus or minus the square root of b squared minus 4 times a times c over 2a. In this equation, a will be 2, b equals 3, and c equals negative 1. We fill in our values to get negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 1 over 2 times 2. We simplify to get negative 3 plus or minus the square root of 9 plus 8 over 4, or negative 3 plus or minus the square root of 17 over 4. This can be expressed as negative 3 plus the square root of 17 over 4, and negative 3 minus the square root of 17 over 4. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.